Hello all. Today we are solving LeetCode problem number 190, reverse bits. So we are given a reverse a bit of given 32-bit signed integer. So we are given as 32-bit signed integer, which for example we are having this number 43261,596, which can be represented in the form of 32-bit within the 32-bit signed integer. So you have to reverse the bit and you have to return the value in the base value in the integer format, which is based on format. So example, you are given this number and this can be represented in the form of binary 32 bits, and you have to reverse this and you have to return the based on representation of that binary number. So as you can see, while reversing it, this we can see clearly that this 100 or 100 is reversed. So it starts with 001 and followed by 11, and it goes on like this. So this is how you have to reverse it and you have to return the answer. So how do we solve this? This is very pretty straightforward. You will be using a result which will be initialized as 0, and you have to perform left shift to create the space or the space to store the bit value, right? And you have to then add it with the last bit of this given n, so which is nothing but the 0. The first it starts with 0, so you have to take the last bit and do or add it with the result, and then you do what you do is you have to go move and fetch the next bit, which is nothing but this 0 from the right. So in order to do that, you have to perform right shift so that this 0 goes out and this 0, the second 0 becomes uh, the last bit of n, right? So because of that, first what you do is result will be initialized with 0 and left shift for space, and then you add result with the last bit value, which is nothing but which can be obtained by n modulo of 2, so which will result in the last bit value. So you have to OR it with and you have to save the result, right? And then you have to update the last bit of the nth value, which is nothing but it should be right shift, so right shift by 1, right? So this will result in updated n. So with this we will be solving this problem, we will be getting the reversed value. So let me show you a try run so that you will have a very good understanding of this approach. So we start with the result equal to 0, and we start by doing the left shift so that it creates a space in the last last creates a space for the last bit, right? So now we add this result with the we have to find n, sorry, this should be n modulo with 2, right, which is nothing but will be 0 because this is 0, this starts with 0. So sorry for this, result or with 0 is 0, so the result remains 0, right? So this is the first part, and then you have to do right shift for the n. So what happens is the n value, the binary value, it's get updated by last it will be, as per the example, it will be 10, and then what happens is you have result equal to 0, and now you have to create the space for the second bit. So first value is 0, which is which is nothing but the last value being reversed, and it is the first value of the answer which we are going to return, right? So it is 0, and again it is same 0, so we will be doing result or 0 is 0, so hence the result will be 0, and moving to third iteration, and n will be last ending by 1, right, because right shift. So now again it is 0 0, and result or with 1 is equal to 0 0, and this 0 with 1 because this is the space being created, and this will be, I'm so sorry for this, 0 0 1, which is nothing but you get the updated result to be 0 0 1, and we continue this for 32 times, and then we when we are done with after iterating 32 times, we return. So this is all about the approach. So let us go ahead and code this up. So this is very simple. So we have to have a result be 0 and iterate for 32 times. So for I in range 32, we start by creating space, which is left shift. Result is this should be left shift, right? So left shift by 1 to create the space, and result or with the n modulo 2 value, right, and you get the, then you have to do the right shift, so by 1 for n value, and then you go and return result. So that is it. Let us run it, submit it, and there you go. Thank you.